In this video, we're going to discuss finding the magnitude of a given vector. Magnitude you can consider to be the length of your vector or distance. When we think of the magnitude as being the distance, we can talk about a vertical component, we can talk about a horizontal component, and we know that verticals and horizontals create 90-degree angles. When we're looking for the length of that vector that has a vertical and horizontal component, we're going to be able to use Pythagorean theorem. The magnitude of vector v is written with double bars. These double bars mean magnitude. So the double bars mean magnitude. Now recall that when you have component form, your horizontal component is the first value in the pointed parentheses. I'm going to do a better job at making those pointed parentheses. And the second component is your vertical component, V2. And that's what we are going to be doing here is we're going to be using those components in this formula. So our horizontal component, V1, our vertical component, V2. We're going to use some more color here, vertical, horizontal. You can see that the magnitude of V is going to equal the square root of V1 squared plus V2 squared. That is just Pythagorean theorem. So let's find the magnitude of vector u given its component form 7, -4. So the first thing I'm going to do is I'm going to write the vector inside the double bars, and that means magnitude. And magnitude is a numerical value. It's a scalar value. It's equal to the square root of 7 squared plus -4 squared, which is the square root of 49 plus 16, which is the square root of 65. And 65 does not break down, so this is an exact value. And if we want a rounded value, it's approximately 8.1. I would go out 3 decimal places, but 8.1 gives you the idea of your approximate value. So I just want to make sure that we know that we're talking about an approximate because that's an irrational number, square root of 65. Okay, you go ahead and try, find the magnitude of u. Press pause, and when you're ready to reveal the answer, come on back. Okay, welcome back. You should have gotten the magnitude of u is equal to the square root of 3 squared plus 19 squared, which is 9 plus 361, which is the square root of 370. Now 370, we're going to see if 370 breaks down. It is, let's see, 5 goes into that. 5 goes into that 37 times, and it is a prime. It is a product of 3 prime numbers in which there's no pairs. So it doesn't break down, square root of 370, or approximately 19.2-ish. 19.2-ish. So good job. Give yourself a pat on the back. We got that simple magnitude going on. Let's talk about scalar multiplication. A scalar is a factor. So if I have this scalar k and I multiply the vector, the component form of a vector, by a scalar, it's not going to just impact one component, it's going to actually impact both components to maintain the direction. So think back to an earlier problem where we had u and we needed to find 3u. That was scalar multiplication. So how would we maintain, remember it was 6 and then it was 4. How would we maintain that? Well, having 3 u's made our horizontal component become 3 6's, which was 18, and then 3 4's, which is 12. So 18 12 would have been our horizontal change and our vertical change. So you can see that that scalar of 3u impacted both the horizontal and the vertical component. Therefore, it makes complete sense that when you have that scalar, you're going to multiply it through to both values in your component form of your vector. When we add vectors in component form, you're going to add horizontal plus horizontal. So add the horizontal components. I'll spell it all out, components. And then you're going to add all the vertical components. And the sum of each will be your resultant vector, A plus B, or in this case, U plus V. Now notice the terminology they have there. U would be U1, U2, and V would be V1, V2. Sometimes seeing this vertically helps. You're going to add your horizontal components, U1 plus V1. You're going to add your vertical components, U2, V2. And that's how you get U plus V. Now when you subtract your horizontal components and you subtract your vertical components. So here we're going to have an example. Given V is equal to 4, 2 in component form, find negative 2V. So this is just multiplying a vector by a scalar. It's actually changing its direction because of the negative sign. It's going to make it turn into a complete 180. So I'm going to have negative 2 times the vector V. So I'm going to substitute in, look at this. So in place of V, I'm substituting in 4, 2. And now I'm going to distribute that scalar, and I get negative 8, negative 4. So what this means, negative 8, negative 4, if we wanted to maybe draw a picture or a sketch, wherever my initial point is, let's move it up here, wherever my initial point is, I'm going to go left 8, 2, 3, 4, 5, 6, 7, 8, and we're going to go down down 4, so negative 4, 1, 2, 3, 4. So here's my vector that is negative 2V. Now what was the original vector? The original vector had a component form of 4, 2. So 1, 2, 3, 4. Positive 4 goes to the right, and then up 1, 2. So there's the original vector. Now I'm just going to take this original vector and look. It's going to have the same direction going in the opposite way because it's a negative 2. So it's going to do a complete 180. And then it's going to land on itself. It's just that the arrow is going to be going the other way. And look, that's 2 of them. Now that is pretty cool. Got to admit, that's pretty cool. Cool stuff. Okay, let's do another. And actually, I think that we're going to have you try this. Given U is equal to 2, 3, and V is equal to negative 5, 1, both in component form, let's find these 3 things. Let's find U plus V. Okay. Then let's find U minus V. And then we're going to really challenge you here. Let's find 2U minus 5V. Press pause and we're going to come back and I'm just going to reveal the answer for you. Okay, thanks for coming back to check your answer. U plus V is negative 3, 4. U minus V is 7, 2. And 2U minus 5V is 29, 1. So here I'm going to come off to the side. If you got those answers, you're fantastic. If you need to find out what you did wrong, I'm going to quickly show you. 2 plus negative 5 and 3 plus 1. That's where U plus V is coming from. And then the next one, U minus V. That was 2 minus negative 5. And it was 3 minus 1. And that's what got us 7, 2. And then 2U minus 5V. 2U minus 5V. So 2 times 2 is 4. And actually, I'm going to do this in a better way. I'm going to tell you 2U is equal to 4, 6. And then negative 5V is equal to 25, negative 5. And then 2U minus 5V is the same thing as 2U plus negative 5V. And that's where the 29, 1 came from. So working vertically, you could see I really couldn't continue to work horizontally because I knew working left to right, I was just going to make a mistake. So working vertically is a good tip for you, and hopefully it works for you. Now in the next videos, we're going to really go into depth about how we work with vectors. So we'll be talking about unit vectors, finding direction. That's going to be very important right here. So we'll be finding direction, we'll be working with different forms, linear combinations. It's good stuff. Good stuff, all in preparation of being able to work with application problems.